The tutorial you're about to see is a part of a 5-star rated Udemy course, Arduino 0 to Hero. It also comes with its own specialized Arduino kit by DFRobot. Check it out, both links in the description. Hello and welcome. In this tutorial, we are going to create a voltage divider circuit. Now, this is a pretty important concept in electronics, and I'll first try to explain it on the schematic, after which we're going to build a circuit and illustrate what I'm talking about. So, imagine that you have a sensor. And that sensor is, an analog sensor which is going to give you a value between 0 and 1023. Now, you can think of 5 volts as 1023, and you can think of G and D as 0. So you set up a circuit that looks like this. A device that varies in resistance connected to the 5 volts, and a device that doesn't vary connected to the G and D. By the way, you can do this upside down as well. We're going to do it in both directions. So, as you can see, when this variable resistor, when this is really low, or let's say it's 0, you're going to be connected directly to 5 volts. You'll be reading 1023. But this here being a 10K potentiometer, if this was 10K, then this 5 volt would be divided 2.5 volt here and 2.5 volt here. So this reading that we're going to be having is some value between like 500 and 1023. So that's what we're going to try to achieve. And then conversely, we're going to switch these around, and we're going to see if what we get is a value between 0 and 500. So let's get started. Let's start with just getting an analog reading. So I'm going to put this into A0. And I'm going to leave it sort of hanging out. I won't even put it into the breadboard. I'll leave it hanging. And you'll have a reading. And it won't be a meaningful reading, but it'll be a reading. So I'll just stab it in. There it is. So let's open up a program. And we're going to have, a variable, call it integer reading. And we're going to initialize that to 0. Then we're going to pin mode A0 is going to be our input. And here we're going to say reading equals to analog read A0. And then we're going to print it. Serial dot print ln reading. Now this is not going to work yet because I haven't initialized the serial, which is going to be here. Serial dot begin 9600. Okay. Oh, we need a delay. Delay anything. 50. So 20 times a second we should be getting an analog reading. I'm just going to save it anywhere. And hopefully, when it's done uploading, we can check the serial monitor right here. Boom, boom. So as you can see, it's sort of like giving you random values. And if I take it into my hands, it's sort of oscillating between 1023 and 0. It's chaotic. But if I were to put it into a minus, it would be straight up 0. If I were to put it into 5V, it would be straight up 1023. So let's check our initial theory. We're going to get a variable resistor to go into the 5V. And there he is. I mean, we just grab a wire now to connect that. And we should be on a 1023, no matter how much I turn this wheel. It's constantly 1023. Now watch this. This could be interesting. I think this is a 10K resistor. You can always take a little, we're going to know immediately. Because if it's not. Okay, so my theory was it's going to go from about 500 to all the way to 1023. 514, 1023. So there you have it. And if we were to pop that around, so have it the opposite way, so say connect that directly to minus, it would go from 0 to 500. Boom, boom. And connect that to that, and then connect the 10K to... So it would top out at 500 and go down to 0. It's kind of more convenient to just to do it the other way. It looks neater, so I'm just gonna control it from that 500 to 1000. So let's now use that to write a value to an LED. And you're gonna observe something interesting. I can't wait to show you. So as you can see, the analog read goes between 0 and 1000. Next, we're going to use an analog write. And we're going to need this LED for that. We're going to put the LED here. That's an LED resistor. We can put it anywhere into the breadboard. And we can get a cable into the first available PWM port. So that's the one with the squiggly bit right there. That's a 3. 0, 1, 2, 3. So we've added an LED, so I can call it int LED red equals to 3. And we can set it pin mode LED red. That's an output now. And interestingly, right here we can analog write LED red. Wait. LED red, we're going to write reading to it. So whatever is the value of our reading, that's what we're going to write to our LED. So we're going to write 514 right now. Semicolon. I don't think I've ever done a program where I didn't forget a single semicolon. All right, let's have a look. 514. Oh, this thing's not. Ooh. So 577, and it's getting stronger, and then it drops to 0. Look at that. So this is where you find out the interesting fact that analog read goes from 0 to 1023, but analog write goes from 0 to 255. Heh. So we somehow need to transfer a value that's between 500 and 1000 to 0 to 255. So I guess we can minus 500 divide by 2. I guess we can have int LED value equals to 0. And then we can say LED value. And I guess equals to whatever is in here. We're going to convert it to integer. So we're going to go reading minus 500. And if 514 was the minimum, so it's going to stay maximum. It's going to stay there. It's going to process the brackets first. I don't know. And we're going to print LED value because at the end of the day, that's what matters. So serial print. I think we're going to have a working potentiometer here that's going to take our LED from nothing to something. Okay. So moment of truth, 137, pretty low. So the lowest, that's 261, and oops, 7. 12. So if we crank it going this way, we are going to go past 255. 261 is still strong. Ah, because we're still writing the reading. We should be writing LED value. I was confused looking at those. And And I think it's still going to have a bit of an error at the very end, which we can easily correct, but let's observe. 137. Perfect. That's practically 0. And now we crank it up and up and up. And when you go all the way to the end, you get to 261. So you've got just a bit too much. And if you made this, I don't know, divided by 2.1, you would probably sort out the problem. You're going to see it right now. I mean, the goal is to get to like 250, 249. Perfect. Whee! That is a perfect LED dimmer. And on retrospect, it would have been easier to organize if I had, where is my schematic? Voltage divider circuit. If I had simply done this the other way around with the potential resistor being attached to ground, it probably would have been a bit easier, but it doesn't matter. You just work with the range you have and you use some simple algebra to turn that variable resistor into an LED reading that is roughly between 0 and 250. Excellent. I hope this was educational. I will see you in the next tutorial. If you enjoyed this tutorial, hit the like button, totally good karma, and do subscribe. A lot more like this coming in 2018. Again, check out the links in the description and the playlist right here on your screen right now.